So guys, welcome to the session on hyperparameter tuning in decision tree. So in previous session we learnt about homogeneity, what is Gini impurity, what is entropy. In this session you will learn about the concept of hyperparameter tuning and how we can reduce the complexity of decision tree. So in this session we will be learning about disadvantage of decision tree, tree truncation, tree pruning, hyperparameter tuning and decision tree regression. I'll just tell you a little about what disadvantage of decision trees are. So first disadvantage is overfitting. So what do you mean by overfitting? The tree can become too complex and fit the training data too closely. This will reduce the generalization to new data. The decision tree will memorize the whole data set. Second one is instability. Small changes in the data set in initial stage at the initial nodes will change the entire structure of the decision tree. Third one is bias towards dominant class. If one class dominates the data set, then the tree may perform very poorly on the minority class data set. Fourth one is limited expressiveness. So decision tree may not capture the complex relationship between the features, especially non-linear or non-hierarchical ones. Fifth one is poor performance of small data set. With limited data, trees may fail to identify the meaningful patterns. So basically, decision tree will always help in those data set which are very large. And the last one is computational cost. So building deep trees with many features can be resource intensive. So the cost is more for building the decision trees. So let me first talk about what is tree truncation. Earlier you learned that decision trees have strong tendency to overfit the data, which is a very serious problem. So you need to pay attention to the size of the tree. So there are two broad strategies to control the overfitting in the decision tree. The first one is tree truncation and the second one is tree pruning. If you talk about tree truncation, then it means that while the tree is growing, you stop the growth of the tree in the middle. That is tree truncation. And what is tree pruning? You let the tree grow to full features and then you cut the branches of the trees in bottom up fashion, starting from leaves. So in this session, I will be taking mainly on tree truncation part. So though there are various ways to truncate or prune the trees, decision tree classifier in sklearn provides the following hyperparameters which you can control the growth of the decision tree. So the first one is criterion. It can be Gini or it can be entropy. So it defines the homogeneity matrix to measure the quality of the split. So sklearn supports by default Gini as the homogeneity criterion. So the next one is max feature. So it defines the number of features to consider when looking for a best split. So if an integer is inputted, then it considers that value as the max limit to split the node. If float value is taken, then it shows the percentage of features at each split. And if auto or sqrt function is taken, then it will be sqrt of n features. Similarly, if log is taken, then log of n features. So this is how max feature plays an important role in splitting the decision tree. The third one is max depth, denotes the maximum depth of the tree. So it can be an integer value. And if it is none, then tree will grow until it reaches the overfitting or until it learns all the training data. Fourth one is minimum sample split. It tells the minimum number of sample which is required to split the node. Fifth one is minimum samples leaf. The minimum number of samples required at the leaf node that will decide the split of the decision tree. So now let us start building the decision tree on Python. So in previous session we created a decision tree based on standard parameter or the default parameters. Now we will change the hyperparameters and we will see how some of the hyperparameters which when changed make the model performance better. So guys, welcome to the video. You saw theoretical aspect of creating decision tree and hyperparameter tuning in a decision tree. Now we will go with understanding as to how decision tree model and hyperparameter tuning can be done using Python. So I'll be telling you step-by-step guide how to create decision tree and how to perform hyperparameter tuning in the same decision tree model. And then we will compare the two models and let's see what is the difference. So there are major 6 steps in creating a decision tree using Python. Step 1 will be importing all necessary libraries and reading the dataset. Step 2 will be putting feature variable to x and response variable to y. Step 3 will be train and test split. So once you have X and Y data set, you have to separate the train and test data for decision tree. Step 4 is importing and fitting decision tree. We will import necessary libraries and we will fit the decision tree model. Initially, we will take the next step equals 3 as the hyperparameter. Importing necessary libraries for visualization and creation of decision tree. And the last step will be evaluating the model performance. So here we will first predict the train and test dataset. Then we will find confusion matrix and accuracy score. Once the decision tree is constructed, then we will go for setting out the hyperparameter tuning. Here case 1 will be, we will create the decision tree without any hyperparameter. Only we will have to take random state. Case 2 will be controlling the depth of the tree. Previously we have provided the minimum depth equals 3. Here also we will do the same thing, or we can change the depth. Case 3 will be minimum sample before the split. A node should have minimum number of sample in order for it to get split. Case 4, minimum samples leave. A node will split if and only if it has threshold number of minimum samples in the leaf. Case 5, we will take entropy instead of Gini coefficient. And the last but not the least, hyperparameter tuning using grid search CV. So without wasting any time, let's jump on to the Python coding. Hi guys, welcome. So let's start with the coding part. Here we have to import the necessary libraries. So import pandas as pd, numpy as np, import matplotlib.pyplot as plt, cbon as sns. Okay. How to read the CSV file? So pd.read_csv, this is the command, and here you have to put the path name. So df is the data frame which has all the information related to art_v2.csv. We check df.columns, then we have these many columns: age, sex, BP, cholesterol, heart disease, and all these are data type are object. So displaying first 5 lines, df.head, we get this data frame. Now defining x and y. So what we will do, we will drop heart disease from data frame df so that we get x, and we will just select heart disease column from data frame df so that we get the feature variable y. Now we will start with the train and test split. sklearn.model selection, this is the library. We will import train test split. So this is how the code is to be written. We will put the train size as 0.7. It means 70% of the data will go to train and 30% will go to test. Checking out xtrain and xtest, this is how the distribution is done. Now we will import decision tree classifier. So sklearn.tree, this is the library from where we have to import the decision tree classifier. Let us instantiate dt as the decision tree classifier object with max depth equals 3, and what we will do, we will fit the xtrain and ytrain which we have received above. Now as we saw in the earlier video, we imported the required package for visualization. We plotted the tree with max depth equals 3. So this was the tree which we got. After that we did the evaluation of model performance. So we defined the predicted values of ytrain and ytest, and we imported confusion matrix and accuracy score from sklearn.matrix library. So there we got the accuracy score as 0.74, and this is the confusion matrix, and accuracy score for test dataset was 0.6. So there is a difference of approximately 14%. This is optional. If you want to do, you can do it. Otherwise, all these commands have to be repeated again and again. So it's better you go for creating such a helper function. Whenever we call this function, then it will do exactly what it has done previously. Similarly, we will create a helper function for evaluating model performance so that we can do the model performance and creation of the decision tree quite fast. So as we discussed earlier, we will go for case 1. So case 1 was without setting any hyperparameter and evaluating the model. So here we will instantiate a dt_default as the variable, decision tree classifier with random state equals 42. So here we are not performing any kind of hyperparameter tuning as of now. dt underscore default dot fit. So we have fit xtrain and ytrain data which we have created previously. Gph equals get underscore dt underscore graph. So this was the helper function which we have created, and dt default is the decision tree variable creating the image of the decision tree. We get this. Here there are no hyperparameter tuning. It means that the nodes are getting split many times again and again, so the decision tree is quite large. When you evaluate the model performance, you get train accuracy is 1.0. It means that this tree has learned every parameter. So this tree has overfitted. One of the disadvantages of decision tree was overfitting the data. So this is the issue. This is the overfitting. And the test accuracy is 62%. Now, what was our case 2? Controlling the depth of the tree and evaluating the model. Let us instantiate a variable with depth. So dt underscore depth, and here max depth we are taking as 3, similar to what we have done earlier. And then we create an image. So we get the decision tree graph. Here evaluating the model performance, we get the train accuracy is 0.74 and test accuracy is 0.60. So it is similar to the previous one. Now let us go with case 3, specifying minimum sample before split to give the hyperparameter equals 20. So what it means, each of this node, if the sample is greater than 20, then only it will divide into two different node, otherwise it will not. So here it is 21, that's why it's going for splitting. Here the sample is 9, so it is not going with the split. It means that if the minimum sample split is less than 20, then it will not split, and if minimum sample split is greater than 20, then it will split. And we get the train accuracy is 0.83 and test accuracy is 0.64. So this is also a huge difference. Now the next is case 4, that is specifying minimum samples in leaf node. Here we will put the hyperparameter min underscore samples underscore leaf equals 20 and with random state. Creating this decision tree again and evaluating the model. So here you can see minimum samples leaf means in each of the leaf the minimum sample has to be 20, not less than 20. So every minimum sample leaf means all the final node you can see minimum sample is here 22, here 25, here 29, here 35. So these are the leaf node, this one and this one. So the leaf node carries more than 20 samples. Evaluating the model performance, you are getting 70% and 64%. So this is quite nearer. So the train and test data set are showing similar accuracy. Now using entropy instead of Gini. So again we'll go for entropy. So here criterion you have to make entropy. Otherwise by default it is taking Gini as the method. Creating the decision tree, the minimum leaf entropy is similar. Okay folks, so we have trained the model, we have tested it, and the model is doing pretty okay. But you know what is missing? The secret sauce, the magic wand, the Gandalf of machine learning. Grid, search, seek. But wait, I'm not going to spill the beans just yet, so you will have to wait for my next video where I unleash the full power of hyperparameter tuning. So inside the chest lies the best version of your model, and grid search CV is the key. So hit the subscribe button, like the video, ring the bell, and I'll see you in the next one.